There you go.
I want to thank you for inviting my co-authors and I to give this presentation on using ground penetrating radar and airborne thermal infrared imagery to detect natural fractures around Old Faithful Geyser in Yellowstone National Park. Next slide, please. So the question we have, and if you could hit the left click, is how can the unique Old Faithful Geyser be protected? And the answer we came up with, if you could click next, is basically to use scientific techniques to quantitatively measure and monitor the Upper Geyser Basin hydrothermal system. Click, please. And for details on this presentation, you can see a published article by myself and my co-authors in Geothermics. And the location of Yellowstone National Park is mostly within the state of Wyoming, but also incorporates portions of Montana and Idaho in the western United States. Next slide. And to provide some context for what we're going to look at in the Old Faithful area, I wanted to talk about Yellowstone geology and the basic geologic structures that influence what you will see in the Yellowstone area. So first off, you may notice a oblong dotted line. That's the 640,000 Yellowstone caldera on the image on your left. Next, please click. And then you'll also notice some solid oblongs within the Yellowstone caldera. Those are the Sour Creek and Mallard Lake resurgent domes. And there are on the digital elevation model, north and northwest trending volcanic vents that are shown by the red stars, as well as black lines that indicate north and northwest trending normal faults. One of the things that's interesting, because Yellowstone attracts so many visitors, is that the area that people come to look at the hydrothermal features is actually less than 1% of the land surface that's shown on the digital elevation model. And on this model, the browns to purples are the high elevation mountains that can range up to about 12,000 feet. And the greens and yellows are lower elevation areas, and they're part, particularly inside the Yellowstone caldera, of a volcanic plateau. Next slide, please. Now, to focus in from the entire park to the Upper Geyser Basin where Old Faithful is located, as I mentioned in the previous slide, it's on the flank of the Mallard Lake Resurgent Dome. You can see it in this basically image on which I've draped lava flows, and the upper right shows the Mallard Lake Resurgent Dome and black faults represented there. Next, click please. And you'll see other rhyolite lava, whoops, you'll see other rhyolite lava flows that surround the Upper Geyser Basin on the northwest, the south, and the southwest. You'll also notice a gray area that the lava flows surround, and that's covered by or represents obsidian sands and then siliceous sinter. On the map that has the Upper Geyser Basin geology, you'll notice a red area, and that is a 2D representation of a three-dimensional hydrothermal system. And it actually is a thermal infrared survey that was done of the Upper Geyser Basin in 2007. Next slide, please. Before we did a ground penetrating radar survey of the Old Faithful area, we did a helicopter airborne survey in March of 2015 that included the daytime visible image that you're seeing here. And you'll notice the Old Faithful Geyser vent, as well as a boardwalk that surrounds it for viewing the eruptions. And you'll also notice the infrastructure of the Old Faithful Visitor Center and the Old Faithful Inn. Next slide. During that survey in March 2015, please go back to the other one, the previous slide. Could you go back to the previous one, please? Thank you. This is basically, okay, so daytime visible, and then the next slide is the same area, but a daytime, basically thermal IR. So next slide, please. And on this daytime thermal IR, you'll see the Old Faithful Geyser vent, and you'll also see another area on the bottom of the image that has warm colors related to heat coming from the ground. And it even looks like it has more heat than the Old Faithful Geyser vent at the time that this image was taken. But you'll also notice that the Old Faithful Visitor Center and the Old Faithful Inn have some solar heating on it. So that's what does happen when you take thermal infrared imagery during the daytime. But still, the Old Faithful Geyser vent and that other area near it is actually have heat coming from the ground. Next slide. So we can look at the thermal a little differently. So here you're seeing the Old Faithful area in thermal, and it's night thermal. So much of the solar heating you saw in the day thermal infrared has been reduced. And you could see a certain pattern with the cooler colors indicating lower thermal ground temperatures and the warmer pinks, reds, orange, yellows indicating higher, basically, ground temperatures. And although this was night 2012, the same pattern of temperatures and also heat could be seen from 2007 through 2015 in every night acquisition that was taken over the Old Faithful area. And the image you're seeing here and the temperatures have been calibrated, corrected, and the temperatures are overlaid on a 2008-2009 LiDAR image of the area. Next slide. Oh, sorry, next click. So the black arrows here indicate places where the thermal system has been impacted by human activities in the area, whether it's the buried sewer lines or they're just old former swimming pools. And there also are places that indicated on the black arrows where snow does not accumulate in the winter. Next click, please. The focus of this talk are the two white arrows. One of them indicates Old Faithful Geyser, and the other indicates the area that has a lot of heat. And again, it's an area where snow does not accumulate, but it does not erupt. Next slide. One of the things you can do when you have a series of calibrated night thermal IR images is to look for patterns and changes from one year to the next. So on the left, you'll see a September 2010 night thermal IR, and I'll call your attention to two linear trends that are basically near Old Faithful Geyser, and they trend west-northwest to northwest. And then on the right, you'll see a September 2011 night thermal IR image, and it's a grayscale image, both of them. And the whites indicate higher, hotter temperatures. And on the 2011, you can see hydrothermal fluid flow on the surface after a recent eruption of Old Faithful Geyser. Now, one of the things we can do with these two calibrated night thermal IR images is actually difference them to look at the change. Next slide. So here you can highlight the change between 2010 and 2011 in the Old Faithful area. And what it does highlight are those two trends. Now you see them in red with a west-northwest trend from split cone and a northwest trend from Old Faithful Geyser and its vent. You'll also notice on the LiDAR base map here, there are numerous cones. There's Old Faithful Geyser cone, split cone, and other former geyser cones. And it was in one of the former geyser cones that you could see the heat pattern. And of course, that area does not accumulate snow in the winter. Next slide. So what we can do is integrate the thermal infrared information that was gathered over the area with a ground penetrating radar survey done in April 2015. Please go back to the previous one. Okay, so in the image on the left, the map on the left, which is the LiDAR map with the thermal trends on it, you'll also see black lines that indicate the places where the ground penetrating radar was moved over the surface to image the three-dimensional part of the hydrothermal system. On the right, you'll see the ground penetrating radar antenna, which is a GSSI 200 megahertz ground coupled antenna. The controller was carried by one of the other team members as they went over the courses that are indicated on the left. Next slide. And looking at the results, so basically what you see here are the thermal difference imagery. So that's kind of your skin temperature showing trends. You also see some dots on the map. They're blue dots and green dots and orange dots. And they basically indicate the places where you had fractures that you can see on the surface. And then below the map, you'll see three slices of the GPR results. So next click, please. On the top vertical slice, you can see the fractures that were detected, and they're indicated by blue dots in basically unaltered center. And in the middle vertical slice, you'll see green dots that were detected in partially altered siliceous center. And in the bottom slice, you can see orange dots that were detected in highly altered center. Next slide, please. And so when we put all this information together, you have a picture of natural fractures, both seen on the surface, for example, on places like Split Cone and some of the other geyser cones, or just in the area on the surface. And then you all have the mapped superficial thermal IR trends from the night calibrated thermal infrared imagery that are north, north-northeast, and west-northwest trends. And the GPR survey itself imaged intersecting northeast and northwest trends in the shallow subsurface, which is relatively about 3 meters depth, and also saw the same fractures as we did in the GPR survey of the west-northwest, east-northwest, east-northeast trending in the center. But one of the things that the GPR survey also did is detected blind fractures that were not visible at the ground surface. And below the map on the left, you'll see a rose diagram indicating the fractures that were seen in the subsurface seen from surface to subsurface. So it's all the methods combined showing fractures seen. Next slide. In summary, we know that we can see shallow subsurface hydrothermal fluid flowing through a network of natural fractures. They're north, northeast, northwest, west, northwest, as well as the intersecting northeast and northwest fractures. We were very impressed with the blind fracture network that was detected by GPR. And we know that both the GPR and thermal infrared are complementary and non-invasive techniques that can be used in the sensitive hydrothermal area. Next slide. My co-authors and I also think that the GPR can be used to detect subsurface cavities and other hydrothermal areas with known hydrothermal explosions. And so on your left, you see a picture of Porkchop Geyser that's in Norris Geyser Basin. And we think that's an area that GPR could have some value. The thermal IR technique that I talked about in the Old Faithful area had been tried previously in Norris Geyser Basin, and it was the success of what was done there that led us to believe that it could also be used or tested in the Old Faithful area. Next slide. So to give you an idea of what we're trying to protect, this is a short segment of an eruption of Old Faithful Geyser, 11 April 2015. And during the GPR survey, of course, we needed to estimate the time that it would go off so that we could be away from the erupting geyser and everyone could be safe. And behind our team members here that you see on the skyline is the Mallard Lake Resurgent Dome. It's covered in a dense forest, but if your eye traces the skyline, what you'll also notice is that it drops down on the right portion of the photograph, and that's actually a graben, or one of the faults in the Mallard Lake Resurgent Dome. So I'd like to acknowledge the many groups that supported this research: the National Geographic Society, the National Park Foundation, and Rocky Mountain Cooperative Ecological Study Units, Pacific Lutheran University, Geothermal Scientific Investigations Limited, and the Geothermal Institute at the University of Auckland, and also the Indonesian Endowment Fund for Education for providing a research grant to conduct X-ray diffraction analyses of the Siliceous Center. And finally, this research was conducted under a National Park Service research permit. Thank you. And with that, I'll be happy to answer any questions.